Hello, Form 2 students. Welcome to our mathematics lesson. And today we start a new topic, service area. I'm your teacher, Mr. Wanyoike from Elite Girls High School. Welcome. Our objectives for this topic are as follows. 1. You should be able to find the surface area of a prism. 2. You should be able to find the surface area of a pyramid. 3. You should be able to find the surface area of a cone. 4. You should be able to find the surface area of a frustum. Number 5. You should find the surface area of a sphere and a hemisphere. The content, we shall be looking at the areas that have been mentioned in the objectives. That is, the surface area of prisms, the surface area of pyramids, cones, frustums, and spheres. Welcome. Solids are objects with definite shapes and sizes. A solid can be regular or irregular. In this topic, we are going to consider regular solids. Surface area of a prism. A prism is a solid with uniform cross-section. The figures in the next page shows prisms with different cross-sections. Learner, let us look at the following examples of prisms. We'll read them horizontally. 1. We have a triangular prism. The cross-section is in the shape of a triangle. Number 2. We have a square prism. A square prism. The cross-section is a square, and therefore we talk about a square prism, meaning the cross-section forms a square shape. Number 3, we have a rectangular prism, meaning the cross-section is a rectangle. The cross-section is a rectangle. Number 4, we have a pentagonal prism. Pentagonal prism, meaning the cross-section as shown there is a pentagon. A pentagon is a regular figure with 5 sides. The cross-section can also have 6 sides, and this will give us a hexagonal prism as shown in the green prism. We also have the blue one that has an octagonal cross-section. Dear learner, do you remember an octagon has got how many sides? Then, if the cross-section of a prism is an octagon, then it forms an octagonal prism. An octagonal prism. Learner, let us look at more examples of prisms. We have a sphere, the one that looks like a ball, a cylinder, a cone, a rectangular prism, we have talked about it, and the triangular prism. And the cross-sections are the ones that are shaded as shown in those diagrams. We'll be looking at more details about them, all these prisms, and how to get their surface area. Let us look at the cylinder in the next page. Let us look at the surface area of a cylinder. A cylinder, I'm sure you have come across it, even when you're in primary school. And most of the tins that we have that once have packed foodstuffs or canned food like roasted beans or maybe pineapple, then you'll find that most of them are cylindrical tins. And it has the shape as shown in this diagram. And if you can imagine that you can open it up, you can open up that tin, that cylindrical tin, then it will give us a rectangle and 2 identical circles. And 2 identical circles. That is in case the tin or the cylinder was closed. But if it was open, Then if it was open on one side, then we only have the rectangle and one circle at the bottom. As you can see, the surface area is therefore made up of two circles and a rectangle. The length of the rectangle is the same as the circumference of the circle. The length of the rectangle is usually the same as the circumference of the circle. Let us look at an example of how to get the surface area of a cylinder. In this example, you are told that to find the area of a closed cylinder with radius 2.8 centimeters and a height of 13 centimeters. So because we have been told that this one is an enclosed one, so when we open it up, then we'll have a rectangle whose length is the same as the perimeter of the circle, and then we also have two circles. So we have a rectangle and two circles. So we need to get the area of the two circles. That will be given by pi r squared, which is 22/7 times 2.8 times 2.8 times 2, because the circles are 2. And then we get the area of the rectangle. The area of the rectangle will be the length times the height, 13. And now the length of this rectangle will be the perimeter of the circle. The perimeter of the circle, which is given by pi d. Remember, radius is 2.8, and therefore the diameter is 2 times 2.8. So we say it is 22/7, which is pi, times 2 times 2.8. That gives us the length, then times the height, which is 13. So the area of that rectangle will become 228.8 centimeters squared. Then the area of the two circles will become 49.28 centimeters squared. So we add the two to get the surface area of this cylinder as 278.08 centimeters squared. Note that for an open cylinder, we don't multiply the area of the circles by 2. So we simply get the area of one circle and the rectangle. Let us look at another prism, that is a triangular prism. So in the prism given below, what is the surface area? So we need to go step by step. Remember, you have two triangles where one is measuring 4 units. The base of the triangle is measuring 4 units. The height is 3 units. And then we have the length of the prism as 8 units. So in triangle 1, we'll have 4 times 3 divided by 2, or a half base times height, which is a half times 4 times 3. That will give us 6. Then in triangle 2, we have a half base times height, which is a half times 4 times 3. That is giving us 6. And then we have the first rectangle, which is at the base, which is 4 by 8. That is giving us 32 square units. Then we also have the other rectangle, which is measuring 3 by 8. That's the blue one. 3 by 8. So it is 3 times 8. That is giving us 24. So the total surface area of this triangular prism is 68 square units. 68 square units. Let us now look at the surface area of a rectangular prism. We use the example below to find the surface area of a rectangular prism. For a rectangular prism, it means that the cross section is a rectangle. In this case, it is measuring 5 by 3. And for us to understand the surface area, we need to remember about the net that makes the surface, the cuboid, or the prism in this case. So you can see it is made up of all the parts that when they are folded, or all the faces when they are folded, they form that particular prism. So to find the surface area of a cuboid, we need to get the area of each face, as you can see in the net, and then we sum them up. So in this case, we can simply do it this way. We can say it is the cross section. We have 2 of them. 5 times 3 times 2, because there are 2 of them, plus 3 times 4, and because there are 2, we multiply by 2. And then we have the other face measuring 5 by 4. 5 by 4, and there are 2 such faces, so we multiply by 2. So when we add that, then we get that the sum area of all the faces is 94 centimeters squared. 94 centimeters squared. Dear students, we have come to the end of our lesson today, and here is an assignment for you to do. Do the questions and upload your work into our Google Classroom platform so that by 8 p.m. tonight, we have the work uploaded. Do your work diligently. In case you need more information on this lesson or any other area, you can contact the contacts or the numbers given in the next page. Have a blessed day.